What's up, guys? In this video, we're going to talk about the scientific method. Now, you may be asking yourself, I've learned about the scientific method time and time again all throughout my school life. Why is it important? Is it important? And the answer is, it is very important. It is the most important thing about science. If you understand the scientific method, which hopefully you do, then you understand probably the most important aspect of science, because it is what science is. Science is not just knowing what photosynthesis is, or knowing what a cell is, or knowing Boyle's law in chemistry, because we all know that. But science is how scientists figure things out. All right. So if we pull up these notes here, hopefully you saw the notes in the assignment link. So it starts off with saying scientific method is a series of steps followed to solve problems. These steps are not always the same for each question you are researching and may not be followed in a linear pattern. Linear meaning, right, a line, straight line, which is how you've learned it in the past. You start here, you go all the way down to here, to your end goal, and you're done. That's not how it actually works. Somebody may have told you wrong. The scientific method might be illustrated better by this diagram. So, this is not a line. This is not linear. This is circular. So, we can start here, making observations. However, if you're working to help further a theory that already exists, maybe this is where you start. And then you move to making observations. What do I see in nature? This can be from one's own experiences, thoughts, or reading. Thinking of interesting questions. Why does this pattern occur? Then you formulate hypotheses. What are the general causes of the phenomenon that I'm wondering about? Then you develop testable predictions, and then you gather data to test predictions. Then, if you have enough data, evidence, maybe then you develop a theory. Or, more likely, you're going to refine, alter, expand, or reject your hypotheses, and you start back over here and develop testable prediction. You test again. You collect data. Then you refine that. Then you collect more data. And so this step right here has to happen a lot before you get to developing a theory, much less something like a law. So the scientific method is very tedious. It takes a lot of time. In any branch of science that you can think of. Scientists just don't do an experiment and say, hey, this is what happened. This is the law. This is how it works. You then have to have other scientists peer review it, perform the experiment before accepting it and moving on. So anytime you see something that is taken as a fact in science, a lot of times it is that way because it is peer reviewed. However, it may not be an absolute conclusion. It's more of an objective conclusion. For example, a highly debated theory and often argued about theory is the theory of evolution. So the theory of evolution, it says, oh, people will say, well, it's just a theory. Well, you're not really giving it credit if you're saying just a theory, because there is a lot of evidence, data, to support the theory of evolution, not to mention the fact that evolution actually happens. So, do not take theories lightly. They are not just theory. They are not just opinions. They are supported by lots of evidence. So, the first step of the scientific method is to state your problem or your question. Develop a question or problem that can be solved through experimentation. Make sure it is something that interests you. That's a very important step. A scientist is like a kid mixing stuff together in the kitchen. My son does it all the time. He wastes things and just mixes stuff together because he's interested, he's curious. That's not something I want to stifle in him. I want to support him in that, but he wastes a lot of stuff. But scientists are interested in this question that they have. And I know that you guys also have questions. So maybe you want to do some research and make some observations. So you can make observations of the act of seeing an object or an event and noting the physical characteristics or points in the event. Observation is an extension of our senses. When we observe, we record what is seen, smelled, tasted, heard, or touched. So then you have qualitative observations versus quantitative observations. So when you think of a quality, it is something that you can see, taste, any of your 5 senses. For example, the apple is red. Red is a qualitative observation. If you bite into the apple tastes sweet. Qualitative observation. However, if I have a bundle of apples, if I have 5 apples, then that is a quantitative observation. Deals with an amount, which is related to a number. The apple weighs 125 grams. That is a quantitative observation. Then you can make inferences, conclusions based on observations. Inferences go beyond what we can directly see. For example, you make an inference when you use clues from a story to figure out something that the author doesn't tell you. If any of you are really big into novels, lore in novels, then you probably like the Marvel series. There are a lot of things that people who are really into the Marvel series will make inferences about maybe the next movie. And so then you can make predictions using observations, inferences, and or trends in data to predict what will happen in the future. For example, if on a sunny day you observe a massive line of dark clouds quickly advancing, what prediction can you make? It's going to storm, it's going to rain, there's going to be some wind. So these predictions are not just made off the cuff, they are made with evidence. And then you do research. In this step, we're talking about doing literature research, not lab-based research. Scientists should read about the research that has already been done on the topic by searching the internet and scientific journals. Good quality research helps in developing an excellent hypothesis. So Daily Express is a news, is a media, used to be a magazine, probably not anymore. Would that be considered as good quality research? Not really. We're talking about actual scientific journals, high-level reading. That is quality research because that is also based off of research and experimentation. Next step is we formulate a hypothesis. A hypothesis is a prediction or possible answer to the problem or the question. All right? So whatever the question that you have that's burning inside of you, your hypothesis is your educated answer to that. It is a relationship between the independent variable and the dependent variable. The independent variable, as you have learned in the past, is what is being manipulated, the factor that is intentionally varied and tested by the experimenter. So whatever you're testing, the independent variable is what you're changing in the experiment to see what your result is. The dependent variable is the responding variable. So if I'm testing the sweetness of different types of apples, this one just came to me, then the different types of apples would be the independent variable. Don't be afraid to yell. I can't hear you. Yell it out. The dependent variable would be what? Remember, we're testing the sweetness of different types of apples. Green apples, red apples. Say it again. Say it loud. The dependent variable is the actual sweetness, the sweetness factor of the apple. You know, there are different ways to test that. Number one, biting into it. All right, and so there's an example. I'm going to skip that because I just gave you an example. The hypothesis needs to be written as if-then statement. If the if part of the statement should describe what is done to the independent variable. The then part of your statement is the prediction of what will happen to the dependent variable. For example, we're talking about Miracle-Gro, which is a fertilizer for plants, if you did not know that. If Miracle-Gro is applied to tomato plants, then they will grow taller. So adding Miracle-Gro to the tomato plants is the what variable? Right, independent variable. Then they will grow taller is your dependent variable. So you are measuring how tall they grow. So the relationship between the independent and dependent variable formulates your hypothesis. So think about that whenever I ask you to formulate a hypothesis in the future. Now we have the experiment. So this is the fun part. This is where the scientist develops and follows a procedure that anyone can follow. Includes the use of precise directions, includes a detailed material list. If you look up some actual legit scientific journals, you will see that the directions are very precise and detailed. If they are not, maybe you want to question that article that you're reading, that journal, in that journal that you're reading it from. The outcome must be quantifiable, measurable, meaning you must be able to collect some numbers from it, some quantity. It cannot just be, well, that one looks different from that one, right? That's not a quantifiable measurement. The experiment must have a control group. A control group may be no treatment or an experimenter selected group to use a standard of comparison for the independent variable. So a control group gives you something to compare your experiment to, right? So if we're testing with this previous example up here, if Miracle-Gro is applied to tomato plants, then they will grow taller. If we're using that experiment, that hypothesis, then think about for a second what a good control group would be. Pause the video. So a good control group would be tomato plants not exposed to the Miracle-Gro. So by not exposing some plants to the Miracle-Gro, then you see what the plants do without the Miracle-Gro. Because using the Miracle-Gro is the thing that you are testing. So then, for the independent variable, maybe you test different tomato plants with different amounts of Miracle-Gro. That's your independent variable. But how do you know how much an effect Miracle-Gro has on the plants if you do not have a control without the Miracle-Gro? So the control group is highly important. And then obviously it would not work without the experimental group. All right, so I only have about 1.5 minutes left in this video. My time is running out. So I'm going to speed past negative and positive control groups and go straight to experimental group. Group or groups that have the independent variable applied / manipulated. For example, in this experiment, the tomato plants that are exposed to the Miracle-Gro those plants would be a part of your control group. All right, so hopefully that makes sense. The next step is to collect data. All right, you must write down results, measurements, observations. So whenever you see how tall they get, you take some sort of measuring device and you measure how tall they are. That is a quantitative data. Now, what would be considered a qualitative form of data talking about tomato plants? Take a second and think. So one example of qualitative data would be maybe how red the tomatoes are compared to other tomatoes, or how big the other tomatoes are, or maybe even which tomatoes taste differently. All right, moving on. Well, actually, I'm running out of time, 15 seconds. So I'm going to stop this video here. I'm going to label it as video numero uno. and then I'm going to finish it in a separate video. So there'll be 2 videos, so make sure you watch both.